Curiosity Corner, your go-to source for everyday concepts. Whether you're an expert in the field or just starting out, our goal is to provide you with high quality and engaging content that will expand your knowledge and ignite your curiosity. I'm Rishika, and I am excited to be your guide on this journey. Together, we'll explore image quality techniques for professional image enhancement in digital image processing in depth, from the basics to the latest cutting edge research. We'll cover everything you need to know, from the fundamental concepts to the practical applications. Whether you're a student, a professional, or just curious about the world around you, there's something for everyone. So get ready to dive in as we explore image enhancement like never before. With our engaging content, expert insights, and interactive approach, you're sure to come away with a deeper understanding and a renewed sense of excitement of the world of image enhancement. So hit that subscribe button and turn on notifications so you don't miss out on any of our upcoming videos. Let's learn together and make a difference in this world. Image enhancement is a fundamental technique in digital image processing that aims to improve the quality and visual appearance of an image. The process involves modifying the image to make it more visually appealing or to extract useful information from it. Image enhancement techniques can be broadly categorized into two types: point processing and spatial processing. Point processing involves modifying the pixel values of an image based on certain mathematical operations such as contrast stretching, histogram equalization, and gamma correction. Spatial processing, on the other hand, involves modifying the pixel values based on their spatial location within the image using techniques such as filtering and edge detection. There are many reasons why image enhancement is important. In medical imaging, for example, image enhancement techniques can help doctors for better diagnosis of diseases by improving the clarity and quality of medical images. In satellite imaging, image enhancement techniques can be used to improve the visibility of certain features, such as urban areas or natural resources. In the entertainment industry, image enhancement can be used to improve the visual quality of movies and TV shows. So overall, image enhancement is a crucial technique in digital image processing that can be used to improve the quality and usefulness of images in a wide range of applications. Understanding image quality. So what is image quality? Image quality refers to how well an image reproduces the details of an original scene of object it represents. It is a measure of how accurately an image conveys the visual information that was captured by the camera or a sensor. There are several factors that can affect image quality, including resolution, noise, color accuracy, dynamic range, and sharpness. These factors are often interrelated, and improving one or may require a trade-off with another. Resolution is a measure of the number of pixels in an image, and it determines the level of detail that can be seen in an image. Higher resolutions generally result in sharper and more detailed images. Noise is the unwanted variation in pixel values in an image, and it can result in a loss of detail and color accuracy. Color accuracy refers to how well an image reproduces the true colors of the original scene. This can be affected by factors such as lighting conditions, white balance settings, and the color filters used in the sensor. Dynamic range is the ability of an image to capture details in both the brightest and darkest areas of the scene, and it can be improved by using HDR, which is high dynamic range techniques. Sharpness is a measure of how well defined the edges and details in an image appear. This can be affected by factors such as lens quality, focus, and image processing algorithms. So overall, image quality is an important consideration in many applications, including photography, medical imaging, scientific imaging, and surveillance. Improving image quality often requires a careful balance of various factors, and it can involve both hardware and software adjustments. Techniques for enhancing resolution. Resolution enhancement techniques are used to improve the level of detail and sharpness in an image. Here are some common techniques used for enhancing resolution. Super resolution. This technique involves combining multiple low resolution images of the same scene or object to create a higher resolution image. Second, interpolation. This technique involves estimating missing pixel values in an image based on the surrounding pixels. This can be done using various interpolation algorithms such as bicubic, bilinear, or nearest neighbor interpolation. Third, deconvolution. This technique involves reversing the effects of the blurring or distortion caused by the camera or sensor. Sharpening. This technique involves increasing the contrast of edges and details in an image to make them appear sharper. Fifth, adaptive filtering. This technique involves applying different filters to different parts of an image based on their characteristics. Adaptive filtering algorithms can improve the resolution and detail of an image while preserving its overall quality. Overall, the choice of technique for enhancing resolution depends on the specific characteristics of an image and an intended application. It is often necessary to balance the trade offs between increased resolution and potential image artifacts or noise introduced during the process. Improving color depth. Color depth refers to the number of colors that can be represented in an image. Increasing the color depth can improve the visual quality of an image by reducing banding or posterization artifacts, which can occur when an image has a limited number of colors. Here are some techniques for improving color depth. Color quantization. This technique involves reducing the number of colors in the image while maintaining its overall appearance. Second, gamma correction. This technique involves adjusting the brightness levels of an image to improve the contrast and color accuracy. Third, high dynamic range, HDR imaging. This technique involves capturing multiple images of the same scene with different exposure settings and then combining them to create an image with a higher color depth. Fourth, color interpolation. This technique involves estimating missing color values in an image based on the surrounding colors. Color interpolation algorithms can be used to create smooth gradients or to fill in missing color information in an image. The choice of technique depends on the specific characteristics of an image and the intended application. Reducing image noise. Image noise is an unwanted variation in pixel values that can reduce the clarity and the detail of an image. Here are some techniques for reducing image noise. Smoothing filters. Smoothing filters. This technique involves applying a filter to an image to reduce high frequency noise. Common smoothing filters include the Gaussian filter, median filter, and the bilateral filter. These filters work by averaging or smoothing the pixel values in an angle which can reduce the impact of the noise. Second, image stacking. This technique involves capturing multiple images of the same scene and then combining them to reduce noise. Image stacking algorithms use statistical methods to combine the images, which can result in a cleaner and sharper final image. Third, non-local means filtering. This technique involves comparing each pixel to its surrounding pixels to estimate its true value. Non-local means filtering algorithms use a weighted average of pixels to estimate the true value of each pixel, which can be more effective than simple smoothing filters. Fourth, wavelet-based denoising. This technique involves decomposing an image into different frequency bands using wavelet transform and then selectively removing noise from each band. Wavelet-based denoising algorithms can preserve more detail in an image than simple smoothing filters. Deep learning-based denoising. Recently, deep learning techniques such as convolutional neural networks (CNN) have showed promising results in image denoising. These algorithms learn to remove noise from images by training on large datasets of noisy and clean images. Reducing image noise can be a challenging problem that requires a trade-off between noise reduction and preserving image detail. The choice of technique depends on the specific characteristics of the image and the intended application. Conclusion. Enhancing image quality is essential in today's digital age. By using the latest techniques and tools, we can create stunning, high-quality images that are sure to impress. However, it is important to carefully select the appropriate technique for a given image and application to balance the trade-offs between improved image quality and computational complexity or potential artifacts introduced during the process. With ongoing advancements in hardware and software technology, we can expect further improvements in image processing techniques and their applications in the upcoming future. Thank you for joining us today.